Happy Wednesday. In class today, you did this warm up on a pink sheet before you took your LTQ. And now that your LTQ is done, we are going to begin talking about solving quadratics using the square root method. Okay. Now, what's really important is that the square root method differs from zero product property in the sense that when we were using zero product property, our equation had to be set equal to 0. But when we solve using the square root method, that is not necessarily true because a quadratic equation can really be set equal to anything, right? Only the zero product property states that it has to be equal to 0. So let's kind of just refresh, right? Let's say we're given this equation in standard form. It's the difference of two perfect squares. And as of right now, the only thing we know how to do in terms of solving a quadratic is to solve using the zero product property, right? So we can go ahead and state that x squared minus 4 can also be the product of x plus 2 times the quantity x minus 2. And both of those are set equal to 0, right? And if both of those are set equal to 0, then individually they can each be equivalent to 0. X plus 2 can be equal to 0, and x minus 2 can be equal to 0. And we can go ahead and subtract 2 on both sides, and we get our first solution is negative 2. And we get that our second solution is positive 2 by adding 2 to both sides. And this is basically what we just took our LTQ on, right? Zero product property. And if you think about it, though, there is another way that we can potentially solve this, right? We know a lot about radicals and we know a lot about square roots from our previous unit. And so what this unit does is it ties in our factoring unit, it ties in our radicals unit, and now we're going to be solving quadratic equations with both of those ideas, factoring, taking the square root, right? One thing that it's really important to keep in mind is that since this is a quadratic equation and the highest degree is 2, right? We essentially are getting 2 solutions, okay? Now, there's an important idea that comes into play. In our last unit, right, we talked about how the square root of, and this is just some side notes, right? The square root of 4 is 2, and the square root of 25 is 5, and the square root of 36 is 6. And the square roots of those values can only be one positive solution, right? The square root of 4 can only be 2. The square root of 25 can only be 5. The square root of 36 can only be 6. And so please, please, please keep that in mind. But also at the same time, this is where the idea of a negative value squared can also be a positive solution. So that's going to come into play here. So in this next section, when it asks, can we solve this same exact equation in another way? Well, yes, we can. And we're going to be doing that by the square root method. So let's go ahead and let's take a look. When we solve using the square root method, we essentially want our quadratic variable on one side and our integer, like a number, on the other. So we're going to start off by adding 4 to both sides because unlike the zero product property, it's okay to have our equation set equal to another value. And now we're looking at an equation that says x squared is equal to 4, right? So now we need to get x by itself. Well, the only way that we can undo something that is squared is by taking the square root of both sides. And when we take the square root of both sides, we get that x is equal to 2, right? But that's only one solution. Now, we know that the square root of 4 is 2 because 2 squared is equal to 4. But the other solution that comes into play here is that x also could be negative 2 because negative 2 squared is also positive 4. And this is that idea now that you have to keep in the back of your mind that we're not just taking the square root of 4, we're essentially solving for x. And when we solve for x, this is where we have the opportunity to get 2 solutions. This is where the opportunity for a positive value and a negative value comes into play. And this is a really big idea. So I'm going to highlight this thought process and draw an arrow to why we get 2 solutions, like why this works. So let's try a few, right? If we take a look at A, we have that m squared is equal to 25. So we have our quadratic values on one side and our integers on the other. So we can go ahead and start by taking the square root of both sides. And we get that m is equal to positive 5 because we know that 5 squared is 25, right? And we also know that m could be equal to negative 5 because we know that negative 5 squared is also equal to positive 25. And we have two solutions, right? With b, okay, we can go ahead and take the square root of both sides. We get that y is equal to, now this is a different way that you can write two solutions. Some of you may have seen this before. We can use this symbol plus or minus, and we can just say that y is equal to plus or minus 1. This represents two separate solutions. It represents positive 1 and it represents negative 1. Now we're actually going to hold off on C for a second and we're going to go down to D. Part of the reason why we're going to go down to D is we know that 16 is a perfect square. You might see an example like D where it's written as the difference of two perfect squares, and it's going to be up to you, like on a test, how you want to show your work. But for this specific learning target, if it's asking us to solve by the square root method, we're not going to want to factor this, right? We're going to want to add 16 to both sides. And now we have the ability to say that a squared is equal to positive 16. We can go ahead and take the square root of both sides, and a is equal to positive 4. A is also equal to negative 4, and you can use that symbol plus or minus. Okay, so now that we've gone through and talked about all of our perfect squares, let's go back to C and let's talk about when something is not a perfect square, like the value of 20. Well, we're still going to start off by doing the exact same thing by taking the square root of both sides. And now we get that x is equal to plus or minus the square root of 20. There's still a positive, there's still a negative, but what we need to now take into account is that we want to get 20 as reduced and simplified as possible. So this is going to come back to that simplifying radicals learning target in the last unit. Well, how do we break up the square root of 20? We can break it up into the square root of 4 times the square root of 5. So now this turns into square root of 4 times the square root of 5. And we know the square root of 4 is 2. So this turns into x is equal to plus or minus 2 root 5, which essentially means x is equal to positive 2 root 5 and x is equal to negative 2 root 5. And there are your two solutions. So you can easily do this with a non-perfect square. Okay, let's take a look at E. With E, now we start to see a little bit of manipulation. We have to handle the 72. We have to handle the 2 out in front. We also have to take the square root. So we're going to do this in reverse order of PEMDAS, right? So we're going to start by adding 72 to both sides. And we get that 2x squared is equal to 72. Now we can go ahead and divide both sides by 2. And we get that x squared is equal to 36, which is great because we know 36 is a perfect square. We can go ahead and take the square root of both sides, and we get that x is equal to plus or minus 6. Or x is equal to positive 6, or x is equal to negative 6, right? And then f is very similar, but take a look, 24 is not a perfect square, so let's kind of see how the dominoes fall, what happens. We're going to start off by adding 24 to both sides. Okay, when we do that, 3a squared is equal to 24. We can go ahead and divide both sides by 3, and we get that a squared is equal to 8. So once again, we're in a situation where 8 is a non-perfect square. So we're going to start off by taking the square root of both sides, and we get that a is equal to plus or minus the square root of 8. So we're going to have to simplify and reduce 8 down. We know that 4 goes into 8, and 4 is a perfect square. So this can become a is equal to plus or minus the square root of 4 times the square root of 2, which means that a is equal to plus or minus 2 root 2. Because we know that the square root of 4 is 2, and we know that the square root of 2 cannot be simplified. So with that, this was just a little introduction into solving quadratics using the square root method. So tomorrow we're going to take a closer look at this and we'll recap this video. But please make sure that you finish this for homework tonight. Watch this video, follow along with the notes, and then we'll recap tomorrow. All right, happy Wednesday and have a good night, everyone.